AI-assisted software architecture with Chris Woody Woodruff.
The AI DevOps podcast is a show for those shipping software using AI, .NET, Azure, and DevOps. Each show brings you hard-hitting interviews with industry experts, innovating better methods and sharing success stories. Sponsoring the podcast is ClearMeasure, a software architecture and engineering firm that implements AI to empower software teams to establish quality, achieve stability, and increase speed. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host. We're helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that AI, Azure, and the .NET ecosystem has to offer. My returning guest today on the show is Chris Woodruff, or Woody. He's back from show episode 262. We were talking about network programming. We'll include a link to that in the show notes. But Woody's a software architect, over 25 years experience, and he loves software engineering, especially allowing applications and services to communicate across networks and through web APIs. He has received the Microsoft MVP awards multiple times in SQL and data and C# in the past, along with multiple years of being awarded the AWS Community Builder Award. And he's a current board member of the .NET Foundation. He lives in Grand Rapids, Michigan, where he explores the many breweries in West Michigan and travels with his family. And he's also a longtime bourbon fan and loves hunting for whiskey bottles. Well, Woody, welcome back to the show. How are you, sir?
I'm good, Jeffrey. How are you?
Fantastic. Better now that we got you back on the show.
Yeah, and, thank you. It's an honor to be a returning guest. So,
thank you. Happy to have you. I like to make sure that our listeners get acquainted with our guests, even the ones who haven't listened to the past episode. And so you're well into the double decade club when it comes to getting computers to do interesting things by writing code and programming. And so, what is it about? Is it about software engineering that pulled you in, but at the same time just kind of keeps you energized all the years?
Wow, that's a deep question. So, I mean, I've been playing with computers since about 81 or 82 when I got a TRS-80 and an Apple II. So I have two computers in my bedroom, kind of growing up. I just like creating stuff. I always wanted to be an engineer. And so I started in mechanical engineering. And then I reached a point where I didn't find mechanical engineering was that interesting, because you're dealing with atoms and you're dealing with the physical constraints of physics. And then I took a Fortran class in college, and it kind of rekindled my computer kind of enthusiasm. And a professor I had in college said, the great thing about software and software development and engineering is it's half art and half like science. And I totally agree with him, because we could be very creative and come up with our own kind of rules when we create software. And I mean, take a look at all the many different types of architecture, like software architecture methodologies that we have today. And there's always people coming up with new ideas on how to create programming languages and frameworks. And so it's this industry is never boring. Let's just say that, never boring.
Yeah, for sure. Well, speaking of not boring, you've been kind of busy and you've given some really interesting talks about using AI and software and the topic around AI assisted architecture. And we see so many stories of what you can do with vibe coding and get proofs of concepts up and running, but then other stories about crashing and burning and a whole bunch of code, but nobody really understands it. So you've been thinking deeply about the architecture angle, given that, okay, well, here's an AI tool that's going to be generating or modifying some code, and what should we think about that? What are some of the big ideas that you've figured out is the right way to go about thinking through this?
Well, I mean, first, let's talk about how AI can, and I don't want to be negative to start, but we do have to talk about how AI fails at this kind of helping us create our software and our architectures. And there's really two types of failure modes. One is the one that makes the news all the time, where AI generates an architecture and the team ships it and it just breaks everything. I mean, AWS has had this issue in the past where their software developers are mandated to use their internal AI tool like 80% of the time, and it's like erased whole systems of software. It's just like erase the software, because I saw this on the old Silicon Valley TV show. Sometimes AI thinks that to get rid of all the bugs, the easiest way is just to delete all the software.
Get rid of the
And
code.
technically that is true, that if you delete all the software and all the code, you don't have any bugs left.
Yeah.
So I can't argue with the logic of that. But if I'm trying not to be funny, but yes, there are two types of failure modes. The one is the one that just happens drastically and very quickly. But there's this other mode that people are not talking about, and I call it the cognitive debt code base, where gradually, as teams and developers are using AI to generate and to add new code and refactor new code and fix bugs, they are not understanding what the AI is doing. It's becoming it's adding this load, this misunderstanding, or a non-understanding of the code, and I think that's the big thing that we have to kind of communicate and be honest with each other, is that the more you use AI, which I use AI every day, so I'm just going to say that, but you have to understand what the AI is doing, or else you're going to get caught with this cognitive load that will kind of catch up to you at some point in the future. So that's kind of where I really started, because I've been burned on a few projects, and yeah, it does catch up with you after some time.
Yeah. If I remember way back, the manifesto for agile software development, it was 25 years ago now. One of the big themes is simplicity.
Yeah.
So, and yeah, I think all of us who've used it can relate to, well, there's a whole bunch of code. Okay, it seems to work and the test passed, but I don't actually understand the design that's there now in the code, and there's a lot of it.
Yeah.
It's like it writes way more code than we would write manually.
Yes, and it can affect many things quickly. So, like a really aggressive software developer, software engineer, in a day can probably cause some damage or some ill effects in a small area, in a small, maybe a few different subsystems of a solution. But AI can cause like issues well throughout your solution if you're not looking and making sure that there are constraints and guardrails on that AI.
Gotcha.
Yeah.
Well, I mentioned, Agile calls for simple, but AI tools don't seem to drive to simplicity. They just seem to drive to more, don't they?
Yeah, they are. I always say AI amplifies complexity. What I do in this talk that we're kind of discussing in this topic we're discussing today, I really try to help people use AI as a simplifier, and that means you kind of prompt differently. You set up, if you're using like Claude code, use skills that keep that AI kind of confined or within a certain lane. And it does go back, and I go back and I discuss the topic of this simplicity first that I've been discussing and writing about for like the last year and a half, which I'm writing a book on right now that should come out in the fall. And AI has a chapter. This topic I'm talking about is a chapter in the book and kind of permeates through the book also. But the three filters that I talk about in the book that also affect how I work with AI is the 2 a.m. rule, the 2 a.m. test, the half rule, and the primary path first. So if I just give a elevator pitch for each one, the 2 a.m. test is, can someone on your team or one of the teams that helps out developing a system, because we know that some solutions and some systems are multiple teams, can one person at 2 a.m. wake up half asleep and fix a bug, or at least debug it to a point where they know where the bug is at? Because so many times, and this even goes back to human developed solutions. So many times we have so much complexity in our solutions that no one person can actually kind of transverse or debug a issue and get to a point where they can say, there's my bug. Either I can fix it or I know who to reach out to like one other person or maybe one team that can help me fix it. So that's a 2 a.m. test that I always try. The half rule is, I always ask teams, can we get rid of half of something? So can we get rid of half of the resources or scale of our cloud solution and still have a working solution? Can we get rid of half of the code? That's a little more drastic, but can we get rid of half the code and still have a working solution for the user? That one kind of understanding. And then the last one is primary path first. And that one is, when we start out building a solution, don't worry about edge cases. As we all get, when we sit in meetings and talk about our systems and business requirements and architecture, we always kind of tangent out about edge cases. I'm guilty of it, because you always want to think of all these different ways that your system could be used. But I've really learned over the years, build the 80 or 90% solution, and then all of the edge cases, sure, you can keep those around, but build those seams to allow you to build those edge cases in your architecture later. Because all you're doing, I say your team and you only have so much complexity budget that you can work with. And complexity budget is how much work that you can do that lends any type of complex thinking or complex results into your solution. You only have so much of that. So you got to use it wisely. And you can't really, like an example, if you and I were sitting in a room and we were building a commerce system that was only going to be used in the US, why would I bring up, hey, shouldn't we talk about like the euro or some other currency? And you should go, hey, like, let's just concentrate on the primary path right now and just stick with United States dollar and English and maybe Spanish if we're going to do another language. Then later, if our users ask for it, or if we see a opportunity to expand in certain places, then we can talk about those edge cases. So really, those are the three filters that I talk about, but we can kind of apply those to AI also down the road. So yeah. So I'm talking a lot. So Jeffrey, please cut me off if
that's kind of the point.
I know, but I like to have a conversation. So you well, no,
those are so right. Yeah. And you mentioned the 2 a.m. things going wrong. That's always the issue of, it works on my box, and then you go into a different environment and it doesn't work. But it seems like as we're all searching for, what are these AI tools really good at? I want to really be able to depend on them for something. and I want to understand how they're designed so I don't accidentally try to depend on them to do something that they're just not going to do for me. And one of the things that comes to mind as you were talking through this is that there is actually no awareness of the environment in which we're operating. There's just not. And I don't see an architectural way to solve that problem. You've got what, 262K of context window. The big ones are a million. Even if we get to 4 million tokens context window, that's not enough words to actually pull in all of the environmental factors that would need to be considered with every with every code change. And of course, there's no possible way to get context about the current production environment while we're in development. We wouldn't want to. And yet, when we think about something to do locally, we're aware of production stresses.
Yeah. And that's what makes humans, us, so much better at the risk side of software architecture and software development. Now, I will say AI writes really great code. It can probably, like, Claude Opus 4.7 is probably a much better coder than I am. But what you hit on was, and what you and I have is wisdom. And that's AI doesn't have wisdom. AI has some smarts around certain areas.
It has fast lookup.
Yes. It has fast lookup. It also does a good job of taking a look at, for the most part, if we prompt it well and build those guardrails, it can code pretty well much inside our kind of vision of what we want to do in a very clear, concise, tight manner. Nothing too broad. But I think where people come in is we bring that wisdom and that experience and the past. Our brains are really good at remembering concepts and remembering good and bad experience that help us drive kind of our vision, and kind of I'm having trying to come up with this concept of we have wisdom. So
yeah. And to go with that, I was trying to explain a similar thing to a colleague a couple days ago, and I said something that came out of my mouth, and I said, "Yes, that's what it is." It's kind of the rubber duck concept. If you just have somebody to talk to, then you'll kind of figure out what you think. And I was struggling with, I was testing out various models because everybody's been struggling with the cost of the large foundation models. And yeah, wouldn't it be great just to use Opus on literally everything? And then I was going way down to GPT-5 Mini, which is like one of the least expensive. And if you have a certain Copilot account, it's actually free. It doesn't even cost anything to run, and it's included. And we're testing, okay, how much stuff can we get GPT-5 Mini to actually do versus, oh, well, you don't have to get Opus to do this. And I realized this. Opus can do some reasoning, but then you get tempted to ask it to do even more reasoning, and then you get disappointed because, oh, wait, or it takes a super long time. Well, maybe I'll just let it finish. Maybe I'll let it finish. And then you wait for a long time, and then it comes back and with a whole lot of stuff to review. Well, that's not what I wanted. And so then I got to thinking, we can spend more computing power trying to get awareness into these models and trying to have judgment and wisdom and really have good reasoning. But architecturally, the generative pre-trained transformer algorithm, it's a language processor and a pattern matcher and predictor. So if that's the architecture, then is it like pushing on a rope to try to get it to have any type of wisdom, or would it be a better use from just a focus perspective to say, it has super fast lookup, it has a super fast speed. I never have to do another Google search for, wait a minute, what was the syntax of this before? Or how do I get this library to do such and such? It's instantaneous lookup in documentation and whatnot. And if I just think, okay, instead of giving it a big prompt and then walk away for a while and expect it to fill in the ambiguity gaps, what if I just actually sketch out my architecture and actually go through the analysis of, what shape of software do I want to emerge here? And then choose a model that's super fast response time, which in a lot of cases is not Opus High because that's kind of slow response time, and just make the wisdom-based judgment calls myself, but let it do the super fast coding, super fast docs lookup, and iterate, boom, and then we have the solution. And all the while, it's exactly the code that I wanted with no bloat.
Yeah, exactly. And so as you were saying all that, what I've been using, and I'm sure you've looked at it, is multi-agent orchestration
Hmm.
is really where I'm focusing a lot of my efforts to understand and see how I can use that to help me. So let's take one example. Example of that is Brady Gaster's Squad.
Squad, yeah.
So I love that because you come in and you tell Squad when you start up Copilot and tell Copilot that you want to use Squad as an agent within Copilot, and you tell it what you're trying to do. And Squad will create a 7-team agent team, and it uses names from like 80s and 90s movies, which I find totally hilarious. But it does give you kind of names like, let's take a look at like the Matrix. So Morpheus is like your software architect, and Trinity is, you have all these like tank and all the characters. Well, each one has a task or a role, like architect or software developer, DevOps or tester. And you always have Ralph as the documenter. But what that gives you, not only does it give you parallelism on your team to do tasks that can be done in parallel, it allows each agent to work with a certain kind of LLM that Squad has figured out is best for that purpose. So like the software architect would probably need like Opus, like Claude Opus 4.7, because they're trying to come up with new ideas and new concepts and how to break down this work. Where like a documenter could use Chat GPT 5.5, a very simple, but that's a great LLM to write. And it seems like the software developer agents, they always give it Claude 4.5 or 4.6. It doesn't need 4.7 to code. 4.5 or 4.6 are very good at coding. So it uses the best LLM that thinks for the job. And 2, it cuts down on tokens, which soon we're all going to be paying for those tokens and not just having a unlimited subscription. Yeah. We're going to really need something to help us out with token optimization.
Right.
But that's the thing about AI is really good at patterns. So I came up, if I come back to my talk a little bit, I did come up with 4 patterns that I use to use AI as a simplicity partner. So if I briefly run through those, the first pattern is the AI powered complexity detection. So this is where you can ask AI, like, if I came in as an architect into an existing team, existing code base, existing solution, I would really use AI to like prompt it to say, hey, where are the abstraction layers that never get exercised? Like, where's the code that doesn't get used? Or which dependencies are used for fewer than 3 functions? Or trace the primary path for a checked out feature. How many files, how many services? So that way you can really use AI to find and detect those places where the architecture has that bloat, or give it like, what would a developer need to understand to debug this at 2 a.m.? Like ask AI to tell you what it thinks is the complex parts. or what you need to do to understand something, and give it that 2 a.m. rule, because that's interesting. The second pattern is AI assisted subtraction. Sorry, my dyslexia is sometimes hard to pronounce certain words. But for this pattern, you want to identify dead code, unused dependencies, orphan configurations. You could prompt to say, if you could only keep half of the services in the system, which half delivers the most value? Like, ask it in its opinion, like, what is the most valuable parts of the solution? Refactor standard edge case logic behind clean seams. Consolidate microservices in the modules within a modular monolith. That's kind of my own kind of soapbox I like. But this one is, if you subtract code or subtract features of your system that you don't need, one, it's going to be cheaper to run. And two, we're always looking for sustainability, like this green software idea. We're going to use less energy, which means less burning oil or burning natural gas, or just using less power. So we're not taking power away from other parts of the grid that need it. Pattern 3 is interesting. I say prepare for 2 a.m. before 2 a.m. So this comes down to, and I did a talk last week on this, and I asked people, when you have AI that writes code and you tell it to build out certain parts of your solution, when you do a pull request, do you also ask it to write documentation, like update documentation for your solution so people can understand it? And so I always say a prompt could be, write a short incident runbook for the payment flow, and document likely failure mode, symptoms, and mitigations. Or what metrics and alerts would help an on-call engineer diagnose issues within 5 minutes? Like, ask these questions that it can tell you and document. Like, explain the system's primary path so a new developer can understand it in 1 hour. Or if a DB connection pool was exhausted, what symptoms would appear in what services and in what tools? So this idea that you use AI to tell you where the problems may occur and keep updating. I mean, AI is really good at documentation. So let it document as much as it can in your system. And then the last pattern is, just let me get through this one. I know, Jeffrey. Pattern 4 is AI assisted code reviews. So this is a simplicity first review checklist. Like, does this change increase services, dependency, or abstract layers? Could a new team member understand this change without tribal knowledge? Does this change make 2 a.m. experience better or worse? And is there a simpler way to achieve the same result? So, so I always say turn AI on itself, or have a secondary AI that is always looking at what the primary AI is doing. I think in today's world, we need those secondary AIs, because we can't review or take a look and understand everything as humans in the AI speed that our primary AIs are kind of spitting out.
And it seems that I love all those questions, because if we were to ask them over and over again, we would get bored, because they were the same questions. But we have to be repetitive for these AI tools. And it sounds like great catalog questions for an auto pull request bot that's just running in. It seems like those the pull request auto reviewers, it seems like those are pretty affordable from a usage perspective, because they're not generating code. They're just kind of looking at what's there and then generating a little comment. And so I love those questions just to be part of a standard catalog, because they're going to find stuff.
Yeah. And a lot of these questions can be put into skills like Cloud Skills or So you can store a lot of these. I have some skills out on my Simplicity First website that people can download to put into their Claude skill folder. And that will kind of help them out. Like one skill is if you're creating something right away, some kind of solution, I always say like, if I'm going to build a web app, the first thing that I look at is don't build a spa, build either a static rendered HTML site or server side rendered. And take a look at that first, because those are easier to implement, easier to test, easier to maintain, and easier to understand. And then, but if you need something more complex, then you move up to that next complexity level. Because so many people nowadays, when they use AI, they just go, create me a website and that does X, Y, and Z. And by default, what do all the LLMs create if you just give it that simple prompt?
Yeah, they create web applications, not just a website.
And what?
Well,
What?
You know what? For .NET, I think I've seen it favor Blazor server side, and then for TypeScript, React. Although I don't know if there's a standard.
Yeah, like test it. If you just go out to any LLM and say, I want you to create a web app to do a to-do list.
Mm-hmm. Oh, and you don't even
give
specify .NET versus TypeScript or anything.
Yeah, don't even specify anything. It will create a React application with a Node backend and probably a Postgres database.
Mm-hmm. Yeah, websites don't need a database unless you actually have data.
Yeah, and you know what? A to-do list you can create with server-side frameworks.
Yeah,
so you don't have to worry about JWT identity and two code bases, one in the front end, one in the back end. But that's the thing, that AI was trained this way. Like I would say, the bias of AI is because it was trained that way. It was trained on all the code from like GitHub, and GitHub has probably a majority of all of its website, web app projects are probably majority is React and other SPA front ends. So that's what's going to favor.
Yeah.
It's going to favor complexity because that is what has been fed into it.
Yeah, good point. You had mentioned asking it questions to explain certain things, and it got me thinking all of the use cases that fall into the category of deriving something from what you have is what these language models are really good at. You feed it in something and then say, okay, derive something else from it, which is different from coming in cold and then asking a question as if it's just some oracle that knows everything. And so and if any of the listeners just look at the transcription, you can get this. One of the things that I've come to do pretty much every time now that I come into a code base and I'm seeing it for the first time, I'm learning it for the first time, I'll give a prompt that says, review this entire code base and generate a set of architecture diagrams using plant UML and the C4 template, and then render it to PNG files. And so that right there, it'll use the plant UML text-based diagrams with the graph viz engine embedded in it, which is the best layout engine that I'm aware of. And quickly in a code base that I have never seen before, it's like, okay, now I can get some pictures and I can see just what the general structure of what the shape of this thing.
Yeah, I do that too. I come in and I ask it to do architecture models and not that same way that you do, but yeah, I mean, I use like Mermaid and I use C4 the C4 templates and it's really good at explaining things because it's very thorough. It's much detail oriented than the human mind can do. It doesn't get distracted by being tired or thirsty or anything like that. So it will, and it does exactly what you tell it And it's really good at doing that. It's really good at reviewing and understanding and then outputting that information for you to understand. But like I said, there's so many different ways that we can take it one step further and ask it certain things to tell us where like dead code is, or like tell me the maximum dependency loops or not, or jumps. Because that's the other thing, is how many systems have been built where you have like 7, 8, 10, 12 abstraction layers. And every time you create a new abstraction layer, you're putting information on the stack and then having to pull it back off. I mean, so if we can try to tighten all that code down to a lot less abstractions, which abstractions are good if you don't have too many of them. I've seen architectures and systems where I'm just hopping through like classes and it's just going all over the place. Because that organically it has kind of been evolved like that. That's where AI is really good. It's if you tell it, hey, go out and take a look at all these abstraction layers and come up with a plan to get rid of or refactor some of those abstraction layers out as much as possible. And you'd be surprised at how well it will come up with ideas and plans for that.
Yeah. Well, as we close up here, I want to just ask a really tactical question. What models do you find yourself using the most, and what AI tools do you find yourself using the most these days?
So I use, for coding, it's a combination of Copilot with Squad, and also Claude Code.
What flavor of Copilot? Command line, VS Code?
I use the CLI. I use like Writer, and I just open up a new terminal, and I just run Copilot with Squad in the terminal.
Gotcha.
and work it like that. I do use Claude to kind of normal Claude. I don't really use a lot co-working, the Claude Code working, because I just don't need it right now. But Claude Code, I use Claude Code for sometimes if I need to understand something and I just need one agent to kind of work through a problem, I'll use Claude Code, either 4.6 or 4.7. But like I said, I like Squad because it can use all of the different LLMs that Copilot allows you to use.
Yeah, for sure. Okay.
How about you? What do you use? I'm curious what you use.
So I spent 2 months just using Cursor with Opus 4.6 heavily, and then it is the prices keeps going up and up and up, and then I realized that Copilot CLI with the premium request model is way more affordable, especially when you could give Opus give it 15 different steps and have it work for 8 hours overnight, and it's 3 premium requests, which a premium request costs 4 cents. And now I think they're going to API based billing starting June 1st. So we'll see what happens with that. I've used the Claude iPhone app just on the go. I've used Claude CLI. I just started playing around with the new Grok coder that was just announced recently this week. I'm really trying to give all of them a fair shot. I've used Junie inside JetBrains Writer. I'm trying to look through all of them just to figure out that, yes, the model is one piece of it, but then the actual coding harness provides a lot of value, and they're not all the same, and they're all trying to get better, and they're all trying to learn from each other and leapfrog. So it's like the one that I am getting good output from one day, you know what? Sometime from now, all of them will do that well because they're all investing.
Yeah, and I am trying to look at local LLMs. Like, can I leverage a local LLM so I don't have to worry about like those external LLMs that tokens cost money. So like I just started the other day, why I'm looking this way is I have a old Mac Studio. It's not super old, but a Mac Studio that I loaded up Unsloth on, which looks very much like Claude, like the Claude web front end. And you can download different LLMs and from what's the something face? Hugging face. Yeah. So you can download different LLMs and use those different LLMs. And so at some point down the road, I think having a local LLM to do certain things, like I'm hoping that we can maybe have a very specialized .NET C# LLM that we can run locally. That software developers won't need to use the frontier LLMs all the time.
Well, I've downloaded the new Google Gemma 4, also the Gemma 4 27 billion and the Gemma 4 31 billion dense model. And the 31 billion dense model, I have to take the context window all the way down to 80,000 for it to run on the RTX 5090, which has 32 gigs of RAM. Otherwise, it just spills over to the CPU and then it slows molasses. Yeah. But you're really limited with an 80,000 context window. Whereas I can run the 27 billion at 262K. And what I realized was, okay, giving it multi-step coding tasks, it's not going to quite do it, but it's local and it's super fast. Although the Gemma 4 128K model, which is, I think it only takes up 14 gigs of VRAM. So it can also run on the RTX 5070 Ti and those type. It is so fast, I can't even read. I have to scroll back up and see. So I'm wondering if it is, we're used to all these models where we send off a prompt and then we wait. And then because we're waiting, we want it to do the right thing first time around and not come back to it and then realize, oh, that was just a waste of time. But then, okay, what if we just use a smaller model? And by the way, there's a lot of computers that have 16 gigs of VRAM. And instead of having to go for one that's 32 or go for, even the 90 with the Mac Ultra, the Mac Studio Ultra with 90 gigs of VRAM. And, the price just goes up and up and up. But I'm thinking, okay, if Gemma 4 or that type of model is insanely fast response times and it's looking up things and I'm generating code at the class level and at the file level and just going through my own developer loop of, test-driven development and just narrate like, boom, the function is done. Well, that's actually faster than I could type. And I'm reviewing it in line and then going to do the next thing. Then there's never a waste of time because I did exactly what I wanted, but I never had to Google search. I never had to look at some docs. I never had to bang my head against the computer. It's like, man, why isn't this API working like I wanted it to work? All that stuff is just super fast. And the prompting, and then I can use those text-to-speech AI tools handy versus just, there's more of them coming out there where you can just talk to your microphone and then boom, there's a prompt and then figure out the multi-window, where you have a prompt on the left and then your cockpit IDE in the middle, and you can just go.
And then you can hook up your laptop to your desktop, which has your big 5090 and it has the 128 gig of RAM and stuff like that, which in today's market, that will cost you about $20,000. But
no,
in the future,
not quite.
Well, no, what I mean is, I think in the future,
around 6,000.
Like I have a Mac Studio M2 Max with 32 gigs of RAM, which I can load in. I can't load in the big models, the super large models. But I can load in a medium-sized model that will give me enough. But like you said, if it produces code faster than you or I can type it in, that's still a win, and I don't have to pay $200 a month to Claude or Anthropic to have Opus or the lesser models, which still cost money. So,
right.
So I think local is going to be where in a year, everyone's going to have hopefully a decent local LLM.
Well, and for any users who haven't checked out AI Foundry Local, it's Yeah, you have Woody, but I tried it for the first time a couple weeks ago and just had that aha moment that they've curated a set of small and medium models that are proven to run on system on a chip, and then medium like Raspberry Pis or just the small little edge computers where you only need to do a little bit of inference. Like if you had a tiny little camera and just ask the question, hey, what's in this image? That little type of inference.
Yeah.
Or listen to a microphone and like sound detection. I mean, just all kinds of little things where I'd like a little bit of AI inference here.
Yeah. I think we're onto something, but yeah, it's just the hardware. I mean, the hardware is just so expensive. Like, how much is a
For the big stuff, yeah.
5090? Like a
Right.
32 gig 5090 is like
$4,000 by itself
$5,000.
now. Yeah, it's cheaper if you bundle it by buying a computer at the same time if you're in the market for a computer. But
Yeah.
I don't think it's worth it right now for people to go out and do that. Actually, I think what's a better use of the money is to just use like GPT-5 Mini or just use one of the commercial tools. Get the basic plan, and then use the models that are the bottom tier that you're going to get the most out of.
Yes.
And pick and choose when you want to use the expensive models, because you might do a prompt and it ends up being a $5 prompt or a $25 prompt and you just don't know. But these for what we call small models today, that was the entirety of ChatGPT in 2022.
Exactly.
So they can do some pretty interesting things, just not the prompt and walk away for lunch type things.
Yeah. And it's going to be interesting. I also do a talk around, or I have the last few years done talks and done a bunch of blog posts around genetic algorithms. So we also have to think about what artificial intelligence techniques beyond just LLMs, because there are. I remember my first AI was doing expert systems back in the early 90s.
Yeah.
Genetic algorithms, which are really great for finding solutions that humans can't even think of. So look into genetic algorithms and how people use those to come up with new solutions. Very good. But we have to figure out a way to take all these different AI techniques and bring them all together to because there's also like pattern recognition, which is a totally different realm of AI and machine learning and stuff like that. That has nothing to do with LLMs. Also,
Yeah.
Lots of good stuff out there.
Good stuff. Woody, thanks for coming back on the show and chatting AI assisted architecture with me. This is great.
Hopefully I didn't babble too much and go all over the place, but yeah, thank you. I appreciate you having me on and letting me share my ideas. So
Yes, sir. Thank you very much for doing that. I appreciate it. And until next time, dear listener, keep shipping.
You've been listening to the AI DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and everywhere else. Visit our sponsor, ClearMeasure, at clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.